All right, guys, so this one is, students, graduating students attending their graduation. All right, so 85% attend graduation. This is 96, right? Group of 22 students is selected. And then it says, what's the random variable x? Okay. What is it that I don't have them yet. I gotta go get them in a bit. What is it that I'm gonna count or look at? 85% of them attend graduation, so what's the other percentage involved? If 85% attend the graduation, 15% don't. I like it. So I've got 22 students. What could happen from those 22 students? Just tell me, what could happen based on the situation that the probability references? Don't tell me those 22 students could go get a drink. It has nothing to do with the probabilities they give. What could happen? Out of those 22, how many could do this? No. Not what percentage I expect to do it. How many could do it? All of them, or some of them. I love it. So be just a little more specific, but you don't have to list everything. What's the least number that could attend? What's the least that could attend? 0. You guys with me? What's x always going to be the values for x? I think it's part B. List the values is part B, right? Part A is just what does x measure? What does x measure? Why is x? So x goes from 0 up to what? 22. What do those represent? 0 what? 7 what? 22 what?
The number of students.
Who? There you go. I like it. They gave it away right there. Right? The percentage they give you describes the situation that they're looking at. Right? Does that make sense? I mean, if I say 13% of Americans like to go water skiing on Saturdays, right? Then I must be talking about the number of Americans going water skiing on Saturdays. That must be what I'm talking about in this problem, or else why would they bring that up, right? Does that make sense? So it's not, you don't make it up, it's the probability situation tells you what they're looking at. I like it. So there's several that are like this in that section, right? They say, what's the variable represent? Well, then you just look at what the percentage is referencing. And then what are the values? It's going to be 0 up to the total number. Yeah, I like it, maybe. And then it says, this book, I always forget to say this. You're going to see this a lot. All right, so right now there's not much it could be. We know binomial distributions. Today we're going to learn about uniform distributions, and then we're going to learn about normal distributions. So you got the bun going on. So it's B for binomial, and can anybody figure out what's the two most important things to know? And they are the two things the book told me for this problem. What are the two things the book told me for this problem? P, probability success. Why didn't they have to tell me this? We figured it out. So 0.85 is the P. And what's the other piece of information they had to give me? N, 22. So for binomial, it's going to be B and P. For normal, it's going to be mu sigma. Does that make sense? They got to tell me the middle. They got to tell me the spread. Okay. I like it. So that I expect a question on. That's something specific to this book. They made up this notation themselves. But I semi-agree with it because these are the two most important things to know. for this situation. How are we doing so far? You guys all right? Okay. I've already pissed some of you guys off. I'm sorry. I'm sorry I was late. Rough night. Didn't get in the office as early as I wanted to. All right. And then part D is where I finally start calculating stuff. When you see this word, so part D says, how many do we expect to show up? What does that word reference statistically? The mean. I love it. And what kind of distribution is this? Binomial. So what's the mean formula for binomial? I often call it binomial an NPQ problem. NPQ. So what is the mean for an NPQ problem? It's the most beautiful mean formula. N times P. Kick-ass. So that's all you got to do for that one. Right? And then part E is just doing the formula and choose X. Is that cool? Okay. Okay. Sorry, I'm just trying to figure out. So have we addressed the issue or?
I just want to see how it's like set up.
Okay. Cool. Yeah.
D, you said just put N.
No. So this references the mean, and the formula for the mean is NP. This specific problem doesn't ask for the standard deviation. That would be square root of NPQ. Yeah. All right. Is that all right? You guys all right? You can ask follow-up questions. It's okay. Yes?
Can you go over 36?
Oh, okay. There are several problems in a row where they just lay out a situation with values and probabilities. If I can collect all that stuff in this form, I know how to attack it. So 36 has two things. If the card's a face card, I win $30. If it's not a face card, I pay $2. Right? This is number 36. Does that sound familiar? Or some guys are like, it will as soon as I get there. Okay. So it's going to be two rows here. Right? X's are going to have to be numbers. But I can put next to it the situations. I get a face card. I get not a face card. Right? Not no face. Spirited away. Okay, I like it. If I get a face card, what's that worth to me? Yeah, $30. If I get a face card, I win $30. So that's the value that I put right there. If I get something not a face card, I pay $2. $2. So what do I put there? -2. Because it's going away from you. Now they tell you in the problem that there are 12 face cards, and they also tell you there's 52 cards. So what's probably you get a face card? 12 face cards, 52 cards. What's probably get a face card? 12. Keep going. 12 can't be it because it's greater than 1. 12 things that match what I'm looking for out of 22. Out of 52 cards. I like it. What's probability always? The number that matches what you're looking for divided by the total things it could be. So it could be any, you pick a card, it could have been any of the 52 cards. But how many match what you're looking for? 12 out of those 52. So how many don't match the face card? How many are not face? The rest of them. So if 12 are, 40 aren't. So we have figured out if I see something like this, I know how to attack it. I can start multiplying across and then add down, right? If I can just take the situation they tell me about and put it in this form, I can attack it. So there's another problem, number 72. You can do it exactly the same way. So what do I do now? Because it actually asks me, should you play the game? I love this. Not if it's a little dull with the red thing. Don't want to play that game. The answer to do I want to play the game, if I calculate the average, let's just do that. You guys help me out. Do this in your calculator. What is 30 times this? Because that would be how I start to calculate the average, right? X times P of X. What is 30 times 12 out of 52?
6.923.
6.923, sure. And then what's negative 2 times 40 out of 52?
Negative 1.538.
Is everybody cool with that? Sorry, no, not yet. So you got to go back and get it. Now if I add those, I'll get 5.3. I'm going to try to do this in 3, 8, 5. Is that right? All right. Now what the shit? What does that mean? What that means is, one thing that came out positive, which means if I play this game a lot, I can expect to come out ahead. In fact, I'm going to make on average $5.39 roughly each time I play the game. Does that mean I'm going to win every time I play the game? No, I'm going to lose some, but I'm going to win more often, or I'm getting $30 every time I get a face card. So I can like have 15 not face cards and one face card, and I'm even. Right? So whoever designed this game doesn't know statistics. Right? If you're in Las Vegas and you're designing a new game, you want to make sure this number for the person coming, for me coming to play, has got to be negative. Because that means that money is flowing away from me and flowing to them. Every game in a casino is going to have a negative expected value for us. Because that's money flowing away from me. So sure, that one guy just won $2 million. But 2 million other people lost $5. Casino's like, cha-ching. Right? You guys kind of with me? So they want some games to win, because then more people come in, spend all their money. They didn't win. Oh well. And the casino's like, yeah. All right. Sorry. Still fun to play, as long as you're not gambling addict. It's fun. I'm okay with it. So this number, you guys see how to interpret this? This is the average. If I play 1,000 times, I'm going to average this much money won per game. So is this a good game to play? If you had to pick a game to play, is this a good one to play? On average, you're going to make money. So do you think that's a good game to play? Yes. If this number came out to be 0.07, it's positive, but is it worth it? Maybe not worth it, especially if it's not very fun. This is exciting. Yeah. If it's something fun, you're like, sure, man, I'll play. I know I'm going to probably lose money, but I'll play some fun. If it's negative, then it really depends on what kind of person you are. Are you a big gambler, right? So lottery has a big time, not a big one, but it's always negative outcome for us. But there's this chance at winning this huge jackpot. So if you got the money, why not? If you don't, dear God, buy bread. Shit. Sorry, I always get so sad when I see somebody buying lottery. I'm like, you should really just buy milk and bread. Stop it. All right. Is that better? I mean, so for example, some of the basic things to get is, if this is positive, it's better. If it's negative, it's worse, right? That means money's flowing to me, or negative, money's flowing away from me on average. This does not say shit about a single play of the game. So it's probably a toss, I flip a coin. This probably comes up heads. What's the probability if I flip a coin that it comes up heads? 50%, because there's only two sides, and we're assuming it's a fair coin. So I don't know if some of you guys are like, I don't trust you. But no, that coin's not weighted. It's big. I don't know why it's this big. It's huge. It's like, I said, little coin, flip it. 50% chance. If I flip it once, what the shit does 50% mean? And this is the problem my little brother has, right? Sort of backwards from this, but I won't. Stay with me now. Come on. What does 50% mean? Do you guys agree? It doesn't mean shit for one flip of the coin. I'm not going to get half a head. Look at that. George Washington, he's cut in half. No. George Washington. Huh?
Either is or ain't, basically.
Yes. But there's a problem with just one. Probabilities only make sense in the long run. If I flipped a coin 1,000 times, number one, what is wrong with my life? But number two, right? Number two, how many heads would I expect to flip? If I flipped it 1,000 times, how many times should it come up heads? 500. Wouldn't you be a little surprised though if it came out to be exactly 500? Okay, but it should come out close to 500, right? And we're getting better about defining what close is now that we know what standard deviation is. We could actually define what that is very soon. How close to 500 should it be? The min and max usual values. Oh shit. You guys semi with me? Okay, so in the long run, I expect to make this much money per number of times I won the game. So if I play it 10 times, can I lose money overall? Yes. That's not the long run. Right? The longer I play the game, the closer my average will get to this. How you guys doing? So if I roll a die 12 times, can anybody tell me how many threes you expect? What's the probability I get a 3 with a normal die? I'm not talking about Dungeons and Dragons. You go to 20. No. Normal 6-sided die. If I roll it, what's the probability I get a 3? 1 out of 6. You guys with me? One side, that's 3 out of 6 sides. And again, I'm assuming it's not weighted. Nothing like that. I haven't tampered with it. Right? So if I roll it 12 times, how many 3s would I expect? So what's the probability to get a 3? 1 out of 6. So if I roll it 6 times, I expect to get how many 3s? 1. 1 time out of 6 on average. Does that mean if I roll it 6 times and I don't get a 3, something's wrong with it? Hell no. Do you guys see the difference? Probability is what I expect to happen in the long run. So 1 out of 6 means if I do it a lot, 1/6 of the time I should get a 3. So if I roll it 6,000 times, how many 3s should I expect? Again, what's the probability of getting a 3? 1 out of 6. 1/6 of the time I'm going to get a 3. I roll it 6,000 times. I should get how many 3s? 1,000. You with me? If I roll it, so this is what should happen. If I roll it 6,000 times and I get 198 3s, does that just, I'm not even going to be very specific. Is that unusual? Yeah. Would that be evidence that something's wrong with that die? You guys with me? Is that impossible to happen? But it's so far away, and again, stay with me. I know I'm going off, but I want to get you ready for what we're about to get into. It's so far away in what measures distance in statistics. Standard deviations, z-scores, right? So we could do this whole problem and be very technical about it. But holy shit, I expected 1,000 and I got less than 200. That is evidence that something's wrong with that die. Is it proof? Never. Right? It's not proof, it's evidence. In a trial, if they say somebody's guilty, did they do it? If they say somebody's guilty, did they do it? No. Not necessarily, not no, but you can't say. I don't know. The evidence points in that direction, right? You guys with me? So statistics is a lot like a trial in a courtroom. It just is. Unfortunately, we just can't know for sure, ever. And in statistics, the same thing. That's why I love it, because it's the most true to life. Okay, I went way off on that, but let me bring this back down. So that's how to interpret this. So if I do a expected value and I get negative 0.27, what does that mean? If I do this whole work and I get this, I would lose money on average. On average, each time I do this game, whatever this is, I would lose a little over a quarter, right? Does that mean I'm never going to win the game? No, it just means that overall I'm going to lose more money than gain, right? So if I play this game, I know that if I do it over the long run, statistics says I should lose money over the long run, right? That's why in poker, you play a hand based on what would happen if you had that same hand 1,000 times. So if you're a really good poker player, you're okay with losing some tournaments as long as you know your strategy is based on probabilities that would come out positive over the long run. Because you know, the more and more tournaments you play, eventually your average is going to come out to be positive. That's how you play it. So true gamblers have to be okay with losing, but they stick to the strategy because they figured it out that overall it's going to win eventually. They just have to play enough. And that's why most of us don't have enough money to play enough. Yes?
Going back to the dice, like how would the chart look like that? Like would it be like one,
Oh,
the X
okay.
would be 1 through 6, or would it be
Yeah, it could be.
7?
So to do this though, you want this to represent an amount of, in this case it could be money, it could be if you roll a 1, I'll give you 2 Oreos. And if you with me, it's got to be some exchange of something. Does that, X has got to be some amount of something.
But what if like they have like this 74?
Yeah, I love it. All right.
If you roll like this.
If you roll a 6, you win $10, right?
But if you roll a 4 or 5, you pay $6.
Pay $6, right? Right? You with me so far? See, exactly from what they say I just created. This situation, this happens. This situation, this happens. And then it says, if you roll a 1, 2, or 3, oh no, it said you win $5. Win 4 or 5, you win $5. If you roll a 1, a 2, or a 3, you lose $6. Now, on the surface of it, do you see how this feels like it might have a chance to be a negative value?
Right now, like 6 and then 4 or 5, like that. You don't have to make the whole list.
I'm not sure what you mean. So this is just like face card, not face card. When I roll a 6, this happens. What do I have to put next? What has to go here? What has to go here? Probabilities. That's going to be based off of these situations. Like the face card led to 12 out of 52. Well, the roll against 6 on a normal die, what's the probability of that? 1 out of 6. What's probably a roll of 4 or a 5? 2 out of 6. What's probably, remember? 3 out of 6. Right? And then you multiply that shit. Add them up. It's almost too simple to believe that it gives me a lot of information at the end. If it's negative, I might choose not to do it. Unless I'm a big gambler and I'm like, I'm going to do it. Yes?
As for like, the 1, 2, and 7, wouldn't the 3, 6 be negative?
To never.
No? Even though you're.
What is this column? Probabilities. This is not based on this at all. This is what I get in this situation. What's the probability of this situation? That. What I could have lost $8. That won't change. I could have lost $18 billion. That won't change. Because it's based on 3 chances out of 6. Probability can't be negative. Can't be bigger than 1. I like it. That seems so simple, but when people are doing this kind of problem, they don't even consider that. I see people put 1, 2, and 3 down there. Makes no sense. 300% chance. You're gonna, holy shit. What does that mean? Not only are you gonna lose it, they're gonna go to your family and take $6 from each of them too. There you go. Ha ha. No. You guys kind of with me? You got to look out. That's those basic ideas of probability will keep this right. You got to check it as you do it. What are these all supposed to add up to be? 1. So when you finish making the table, make sure they add up to be 1. Yes.
So, you put in order from greatest to.
Doesn't matter. All that matters is that this is with this is with this is with this. Because the chances you get this, the chances and so forth. So I could have put these rows any order I wanted to. As long as that goes with this. Do you see that? Because you got to multiply this by its probability to get its contribution to the mean. I like it. So now you just multiply across, add down. If it's negative, you might not want to play. How are we doing? This is related to how they figure out. So what happens on the morning of your 25th birthday? We talked about this before. You suddenly don't have to pay as much on what? Anybody know? Car insurance. If anybody's not quite 25 yet, when you turn 25, your bill goes down because suddenly you know how to drive. I don't know. But it's based on probabilities. They say, I expect this kind of driver to cost me this much money, this percentage of the time, to cost me this much money, this percentage of the time, and so forth. And then they calculate how much they can expect to pay, and then they charge everybody a little more than that so that they make money overall. So yeah, they had to pay a bunch of money out for this guy's accident, but everybody else is paying them more than that, so they're happy, right? Maybe? That's how health insurance works too. Right? That's why it only works if everybody's paying it. But let's not go to politics. Stay back, Jeff. Stay back. All right. That's kind of cool. That's how they calculate it. They really do calculate it. And there are people that set the premiums. Their whole job is to pay attention to statistics of accidents and so forth and adjust these probabilities and adjust your rate. Good student, probably a better driver, not necessarily, but it's good enough probability that they adjust your grade down. I'm not your grade, your payment down. And make it like a good student discount. I'm not at, like, I don't qualify. I'm not trying to get personal, I'm sorry. But anybody know that exists? Yes, good student discount. If you're a good student and you don't get that discount, holy shit, go talk to your insurance company, right? All kinds of little discounts for certain kind of things. You have more safety features, well then that certainly correlates to less money they have to pay. So they're gonna decrease your premium. You guys with me? As long as their bottom line is they're making money, they can adjust things so that they're more attractive to certain people. Okay, maybe. Yes?
So with 72, would you put the lottery to get like how much you won?
Yeah, so 72 is a little weird. 72 is that lottery one. So there's a $500 prize, a $100 prize, and 4 $25 prizes. One 500, 2 100, and 4 $25 prizes. Or you can either win or lose. I don't know if you guys remember this problem. This is number 72. It says you pay $10 to get a ticket. So if I get this ticket, how much money did I actually win total? $4.90. So what goes here for this situation? What does this have to do with? True, so it's got to do what in the table? There's one chance to win the $500 out of 100 tickets, right? So how many losing tickets are there? How many winning tickets are there? 7. So how many losing tickets are there? Only 3. What's probably I get the big prize? All right, that's all I'm going to do in that. I'm going to let you guys finish it up. So you just keep going, multiply across, add down. If it comes out positive, you should probably play that game. Comes out negative, it's up to you how much you want to gamble. Yes? You could, totally. Do I? I know enough that when I go play, thankfully I'm not a gambling addict. So when I go in with a certain amount of money, I'm not tempted to go to the ATM and get more. I'm like, once this is gone, I'm done, right? And I know enough that it's like, if I win, that's amazing, and if I don't win, that's expected. I mean, so I just go in and have fun. Yeah.
Do you feel like being a stats teacher or just having this knowledge helps you? Like,
If I was a better poker player, it would be amazing. I wear my emotions on my sleeve, so it wouldn't work for me. No. I'm not bluffing at all. I mean, no, it's no good. So I play with friends for like no money for whatever, But oh my God, I would die so quick if I tried to play real poker. I don't care what kind of size glasses I would wear; it wouldn't do me any good to cover my whole face. Even then, you could just read my. Oh. All right, enough of that. Anything else from homework stuff? So this is related to some work that actuaries might do. I don't know if you guys have ever heard of actuaries. Yeah. Wait. 47 in chapter.
Section
Can't be. This can't be 40.
46.
Wait. Okay.
46.
It can't be 46. I didn't. We don't do section 440. 74. Okay. All right. We just did that one.
No, for E, like
Oh, sorry. 74E.
Yeah, like if add it,
Oh.
like add the
Okay, so once you construct this, where's the expected amount, the expected value? What is that another name for? The mean. And what's the formula for the mean in this situation? So you multiply across